Hey guys, today we're taking a look at the radian measure. Up until now, we've always looked at the unit circle and measured it in terms of degrees, with there being 360 degrees to complete one full unit circle. Well, you can also measure a circle in terms of its perimeter or its circumference. Now, we know that the circumference of a circle is equal to 2 times the radius times pi. Well, keep in mind that the radius of our unit circle is equal to 1. So the circumference of our unit circle should therefore be 2 pi. In other words, within 360 degrees, there is 2 pi. Now, this is going to be known as our radian measure. So following this along here, we just said that the radius of a unit circle is 1, the circumference is 2 pi r, therefore the circumference of the unit circle is 2 pi. Thus, on the unit circle, 360 degree arc has the length of 2 pi. And therefore, a 180 degree arc has the length of half of 2 pi, which is simply 1 pi. So in other words, going from its beginning point to 180 degrees is pi radians. Going from its beginning point all the way around is 2 pi radians. And then going from its beginning point to just 1/4 of the way around is 1/2 of 1 pi. So that's pi halves radians. So we're going to learn to measure some of our angles or thetas using the radian measure. Now, radian is simply the measure of an angle, an arc, or a rotation such that pi is equal to 180. And if we're taking a look here, a couple different notation things. Whenever you see a theta that has a degree mark, this means that we're measuring in degrees. However, if you see a theta that's just given in terms of a number, this means that we're going to be measuring in radians. All right, let's take a look at a few examples. All right, before we get going on our examples today, there's a few conversion factors that are important for us to know. First of all, we often want to convert from radians to degrees. Now, in order to do that, going from radians to degrees, we're simply going to multiply by 180 over pi. Now, if we want to convert the other way, from degrees to radians, we'll go degrees to radians. We're going to multiply by pi over 180. So, for example, it says convert 1 radian to degrees. So, if I want 1 radian, 2 degrees, I'm going to multiply that by 180 over pi. So when I multiply anything by 1, I get the same thing. So this is 180 over pi. And when I do that out in my calculator, I'm going to get 57.3 degrees. So in other words, there's 57.3 degrees per 1 radian. Now let's convert 360 degrees to radians. So now I'm going to go degrees to radians. So I take my 360 and multiply by pi over 180. Well, when we multiply 360 pi and divide that by 180, I'm going to get 360 divided by 180 is actually equal to 2, and that simplifies to 2 pi radians, which should make sense because remember we said within one complete circle there's 360 degrees or 2 pi radians. All right. Next, it says to convert 6 pi's to its degree equivalent. So again, we're going to go from radians to degrees by multiplying by 180 over pi. So that's 6 pi times 180 over pi. Now our pi's will cancel out because I'll have one in the numerator and the denominator. That's 5 times 180 divided by 6. Or if you want to simplify further, 6 divides into 180 30 times. That's 5 times 30, which is 150 degrees. Next, let's convert degrees to radians. So now we're going to go and take our 60 degrees and multiply that by pi over 180. And when I do that, I get 60 goes into 180 3 times. So that's 1 pi over 3, or pi thirds radians. All right, now let's take a look at our calculator, because our calculator, remember, has 2 different modes on it. It has both the degree mode and the radian mode. So it says to set your calculator to radian mode. So we're going to go to mode, down here to the 3rd line, and now press enter on radian. And we'll go back to our home screen here, and it says to take cosine 6. So when I press in cosine 6 now, I get 0.96. This means cosine, or the x-coordinate, at 6 radians. So that gives me 0.96, 0. And next we're going to take the tangent of 7 pi 6. So we'll go back here to our calculator. I want to do the same thing here. 7 pi, tangent of 7, and then my pi is that second function, up arrow. And we'll hit the little divide by 6. And we'll get our 0.577. Okay. Same thing for our next one there. Oops. We'll take sine of pi halves. Now remember, pi halves is 90 degrees, so the sine at 90 degrees is our y-coordinate at 90, which should be 0 over and 1 up. So sine of pi halves should equal 1. So let's check it out and see. And in fact, we do get 1. And we'll go ahead and let you do the last one there on your own. All right, our next example simply says, what mode does your calculator need to be in order to find the following, then give the measure. So here we're just, again, working our notation. Whenever we see sine 12, this tells us that we're in our radian mode. And when we punch that in, we're actually going to get a measure of negative 0.536. Tangent of 5 degrees, now we need to be in degree mode. So again, keeping note of that little notation here. When we punch that in, we're going to get 0.087. Sine of 5 pi 6 is an indication of radian mode. And our measure there is going to equal to 0.5. And then finally, tangent 23 is back to degree. And then we'll get to 0.424. All right, let's take a look at the unit circle now. And you've seen on the inside of our unit circle these little pi's and next to the degree marks. Well, those are our radian measures. So when we want the sine of 5 pi thirds, keep in mind we want the y-coordinate at 5 pi thirds radians. So as you look around the unit circle here, here's pi halves, 2 pi thirds, 3 pi fourths, so on and so forth. As we come around here, you should end up at 5 pi thirds at 300 degrees, and we want the y-coordinate there, which is negative root 3 over 2. Next is the tangent of 3 pi fourths. Now we haven't really talked much about tangent. We know that the cosine is the x-coordinate and the sine is the y-coordinate. Well, the tangent is actually the opposite over the adjacent, which will be my y over my x. Or in other words, it will be my sine theta over my cosine theta. All right, so if I want the tangent of 3 pi fourths, I'm going to take a look around my unit circle here. Here's my 3 pi fourths. I want my y over my x, or in other words, my sine theta, which is root 2 over 2, over my cosine theta, which is negative root 2 over 2. And when I put that over each other here, if we write that out, I'm going to actually end up with equal to negative 1, right? When you have the same thing in the numerator and the denominator, it's going to be 1, but when one of them is the opposite value, it'll be negative 1. All right. Next, let's move down. We'll skip past C for right now. Let's go to cosine of negative pi 6. So if I take a look here at pi 6, the positive direction is 30 degrees. So in the negative direction, or clockwise direction, it should be here at 330 degrees. Now, if I want the cosine of that, I'm looking for my x-coordinate. So that should be root 3 over 2. Next here is sine of negative 7 pi 6. So again here, we're going to take our negative 7 pi 6. So here's 7 pi 6 should be right here at 210 in the positive direction. So if I go the negative direction here, or the clockwise direction, I should end up here at 150. And if I want the sine of that, I'm looking for the y-coordinate, and that should give me 1/2. And that's it. We are done. This is the end. Thanks for sticking it out. Have a great summer.